Hi, permutations. I'm trying to practice backtracking algorithms. I am uncomfortable with them, which is not good. Anyway, permutations. I saw that I can solve permutations problem using backtracking. I already solved it once using recursion, which went something like this. Let's say that we have 5 numbers. Now, a permutation of 1 is you simply take each of these numbers. So that's permutation of 1. But what is permutation of 2? Well, we take one number and combine it with each permutation of 1 of all others. Which means when we take 1, we would append to it 2, 3. There. Now we have 1, 2, 1, 3, 1, 4, 1, 5. Then when we get 2, we would put on it 1, 3, 4, 5. And doing that, so to a number, let's get a simpler example. Permutations of 1 of these are 1, 2. Permutations of 2 is take a number 1. Permutations are for each number combined with permutations before. So permutations of 2, we have 1, 2 and 2, 1. And we can see that's true. And that's, you take 1, so permutation of 2 is take this and combine with the previous permutation of 1 of 2, and then take 2, and recursion is so complicated to explain. And if we have permutation of 3, let's see, we need first permutations of 1, then we need permutations of 2, we have permutations of 1, we take 3, so permutations of 3, which means take this and get permutations of 2 of these, which are 2, 3 and 3, 2, and then we get that. Then the next, take this one and get permutations of 2 of these two, 1, 3 and 3, 1. Now that doesn't look right. Okay, whatever, forget it. Given an array nums of distinct integers, return all possible permutations. You can return the answer in any order, and I am not sure. So backtracking is where is we can use backtracking on problems, on decision problems. And I went here and I read up to here. And they say they incrementally build permutations. So let's try to use this example to figure it out. We have 1, 2, 3. So first we would try to be like 1, they build it. Okay, let's say that's 1. And the next one is I'm supposed from here to backtrack, and here I still cannot generate any. So I go here, and from here I can take 3 and I can do 2. But now I cannot. So now I'm at the empty one as again, and now from the empty one, what decision do I make? We can start from the second element now. That's what I did here. So we take 2 and we can do the same. So take this one and take this one. So take it. So what can I do here? Nothing. What can I do here? I can put 3 and I can put 1. Then I can take 3 and then I can do 1, 2, and from here I can go back here. No, it won't work. So I see some repetition here. So when we have 1, 2, if we want, we can take 1 and we can add 2. So we start with an empty one. We start with an empty one, then we add 1, then we add 2, then we have 1. Then we have to go back to the empty one. Then we have to go back to the empty one. And now we have to go with 2. And now we go with 1. And we are done. So that process where I go back, backtracking, it was this tedious when I was trying to figure out recursion more than 6 months ago. Became fun after. Okay, let's see with 3 numbers. We start with an empty one, we take the first element, take the second element, take the third element, done. Now we have to backtrack to here. Nope. We have to backtrack to here. And from here we can add 3 and we can go 2 and we can say done. And now we can go back. And now we can go back, and we already explored all. And now we can go with the next one, where now I have to add first, and now I add third, done. And now when I go back to 2, 1, nope, because I'm empty. And from here I can say 3, done. I still can't spot anything, but maybe I should continue. But now I would go back to here, and already exhausted all. So now from 3, 3 1 3 1 2 done. 3 1 3 3 2 done. And there we have 6 of them. We start with an empty one, add first, add the next, add third, and now we have to backtrack, because now we need to swap. So here we have a lot of repetition here. Start with an empty, start with an empty, start with an empty. So what I can spot here, when we have 2, and well, what if we had only 1? We start with an empty and we add 1, and that's it. But when we have 2, start with an empty, add 2, 2 1, done, 2 empty, okay, empty, start with a 1, add 2, done. Now with 1, but there are none, so empty, start with a 2, done. So here we can see something, that when you reach length of length 3 1 2 3 2 1, I'm gonna try with 4 because maybe something clicks for me then. And with an empty, go with 1 1 2 1 2 3 2 3 4, done. Now we go here. Can we do something here? Can we swap any 2? No. So I have to go back. I always go 2 back. Let's go 2 back. Here I have to go, when I want to go, I have to go 2 back. Because for every 2 I can make a permutation. At least 2. Because here, from this step, I have to go back to this step so I can build a permutation. 1 2 3 1 2, and from 1 2 I can build a 4, done. And what I notice is that I'm always going back 2 steps to switch this one and this one. And I notice I'm doing that. Where do I notice that I do that? Space here. When I have 1, when I have 2, start with an empty 1, start with an empty 1, add 1, add 2, I'm in the first element, go back, and I go back 2 steps, and from there, so for each element I'm doing that thing for each element. So here, start from 1, so build 1 and go to the next one, accept 1, add, start from 1, and then the next one is 2, and then I go back, and now start from 2 and get the next one. But can I somehow switch the next 2? So if I'm here, switch the next 2. If I'm here, switch that. Actually, when I build 2, I'm always switching them. Here, they are swapped. Because I'm at empty, and then I'm at 1, at 2, at 3, and I'm done. And I have to go back from 3 to 2 to 1, and now I take 3. Once I have it, the current one still doesn't make sense. I feel like I'm having the gist of it. I'll try with 4 to figure out the pattern, and then I'll look at the solution. Here I'm at the end, 1, 2, 4, 3. From here, can I go here? Can I do anything here? I have only 3. Nope. And if I go here, I already swapped the position of the next 2. Not much I can do there. But now I can say 3, 1, 3, 2, 4. Done. And now I have 1, 2, 3, 4. 1, 3, 2, 4. Now I swapped these 2, and now I have swapped these 2. And now if I go back to this step, there is nothing that I can do. 1, 2, but now I can swap 4, 2, swap the next 2. Once I get here, I can swap the next 2. 1, 3, 2, 1, 3, and I already swapped 4 and 2. But now from 1, I can, since I moved 3 there, if I add 4, and now I can do 2, and now I can do 3, and that should be done. And now I go here, but here I can add 3, and now I can say done. And from here, 1, 4, 2, 1, 4, 4, 3, and And now when I say there, I've already done. And when I say 1, 4, 3, 2, and 2, 3, now I'm at 1, and I already swapped all of them, and I reached the end here. And I can say I'm done with these. And now I can start with 2. And now I would need to repeat the whole process again for 2. So there is a lot of repetition, and there is some going back. So when I was doing permutations using only recursion, what I did was for each number, e take a number and all and combine it with previous permutation of all others. If we want permutation of 2, I would say take 1 and get permutation of others to -1, which is 2, 3, 4, and then I would have 1, 2, 1, 3, 1, 4. And for 2, I would say add it to permutation 2 minus 1 for 1, 3, 4, and then I would have 2 to 1 to 3 to 4, which means with that logic this combine to permutations of 2, 3, and 4. Take 2 and combine it to permutations 1, 3, 4. 1, 2, and 4. Take 4, 1, 2, 3. And there you get permutations, which would take you to 1, 2, 1, 3, 1, 4. And here 2, 1, 2, 3, 2, 4, 3, 1, 3, 2, 3, 4, 4, 1, 4, 2, 4, 3. And these are permutations of 2 That's how you calculate them. But they never even saw an opportunity for backtracking there, because I was never looking for it, and I never even knew that it could be a decision problem. Holy Christ. I have a few problems here. One of them, this tells me that 1, 2, 3, 4, 5, 6 times 4, 24. And here of 3, 1, 2, 3, 4, 5, 6. For 3 is 6, and for 4 is 24. Here I would have 24 permutations. Now, okay, since I don't know how to write that into code, and I don't even know how to make a decision, I don't even know the solution. I mean, I know it, but the problem is I don't know the steps which I can use to write a code. What I do know is recursion, thankfully, so I can start there and I can move forward. From recursion to a backtracking step. What I'm repeating here is, let's see, I'm starting with an empty array and I add 1, 2, 3, 4. I reach the whole I'm adding until I have desired length of. Once I have desired length, I go back 2 steps and switch. I go back 2 steps and switch. And from there, I add one after, and then I add this one. And from there, I go back 2 steps No, that's not how I can describe it. So here, empty, add 1, add 2, add 3, add 4, done. Go back. Empty. Is this correct permutation? No. Is this correct permutation? No. Is this correct permutation? No. Is this correct? No. Is this? Yes. Okay, go back. Can I add one more number to here? No. Can I add one more number to here? Yes. Which one? The last one that I didn't use. 4. And what now? I can add the last number. The only remaining one, 3. From there, can I add? Did I use already? Do I have a number that I can use? No. Do I have a number that I can use here? No. Do I have a number that I can use here? Yes, the one after it. Do I have a number that I can use here? Yes, the one before it. Do I have a number that I can use it? Yes, the one after it. Oh my god, I feel like I am missing something. I have to go back. Can I make a correct permutation from here? 1, 3, 2. 1, 3. 1, 3, 4. 1, 3, 4. 1, 3, 1. 1, 1, 3, 1, 3, 2. Okay, now that's better. 1, 1, 4. Okay. I'm just gonna look at the solution now. Okay, my time is off. And it was. Okay, let's see what they say. In backtracking, to generate a permutation one element at a time, we will use array car that represents the current permutation we are building. To start, we add the first element. We are locking in the first value. We will now find the starts with nums 0. I mean, I get that. Damn, I didn't. Well, that's kinda what I was doing. You log it in and you get permutations that start with 1. We start by adding the next element. We now have We are locking this, and we will now start with 0 and 1. If they, I swear to God, this smells like the algorithm I already knew. If they are talking about that one, I'm gonna shoot myself. Joking. This continues until we'll use all elements. Let's say that we have finished start with num0. Now what? By removing the numbers nums1. What? This continues until we use all elements in an example current length number. Let's say that we have finished finding all permutations that start with numbers 0, numbers 1. Now what? We backtrack by removing the numbers 1. Now we have again, now we add the second element that comes after number 0, which is number 2. And now we find all that start with 0. Now once we find the start with backtrack by removing from and adding the next, is very recursive in nature. Duh, I see. Each time we add an element, we solve a new version of the problem. Find the start with current. The initial version of it is to find the star which represents all possible. To summarize, try all numbers in the first position for each number in the first position. Try all other numbers in second for each pair. Try all others trees. Backtracking is by modeling it as a tree. Here, you start with 1, 2, 3. 3, 2. From 1, you can make a decision to go to 2 or to go to 3. And from 3, you only have 1 left. And from 2, you only can make a decision to go to 1 or to go to 3. And from 1, you only have decision. Duh, but yeah, sure. I mean, that's fine. The root node represents an empty current. Solving is equivalent to traversing the tree by using recursion and passing current as an argument. Okay, and what about the rest of the numbers? How are you gonna access them? Solving is equivalent to traversing the tree. The easiest way is by using recursion. I mean, obviously, it's not so obvious. When you have recursion, when you have tree, it's perfectly described using recursion. Is by using recursion and passing current as an argument. Think of each call as being a node in the tree. In each call we need to iterate over that haven't been used yet, not currently in the cur. And how do we know they are not currently in the cur? For each number that isn't, we add it and make a recursive call passing cur, modifying cur and making a recursive call to traversing to child node in tree. Fine. Initialize an answer array and an array current to build permutations with. Create a backtrack function that takes current as an argument. If current length, add a copy of current to the answer and return. Iterate over numbers for each number. If number is not in cur, do the following. Add number to the cur and backtrack cur, then remove cur num from the cur. Call backtrack with an empty cur, return answer. Sure. for each number, if number not in the current append number, and then backtrack. I mean, it makes perfect sense. Huh. Depth first search. Yeah, I mean it is DFS because you go 0, 1, 2, 3, 0, 1, 3, 4, 2, 0, 2, 1, 3, 0, 2, 3, 1, 0, 3, 1, 2, 0, 3, 2, 1. I mean, sure. If you say that, and you say if is sure, and basically for each number, if number is not in the C, yeah, C push number, and we basically remove it because so here for each number here, for each number, is it inside? No. 2, is it inside? No. 3, is it inside? No. 4, is it inside? No. Remove it. And he has to go back. From experience, recursion is not really so understandable by doing that. But here, 1, empty. Do we have 1? No. Do we have 2? No. Okay, and now it simply won't have any choices. And it will be 2. Do we have 2? No. For each number, for each iterate for each number, if number, do the following: unnumber to the cur, and then so that's the backtracking step where they will remove it, add it, if number is not, then remove it, because here we remove it, because if number is not, that's the wrong way to see it. So for each number, if number is not in the current one, add it, and it's gonna basically start here. Is it in the current one? No. Is it in the current one? No. And it's gonna do that for each number, and then it's gonna go with the 2, and then it's basically gonna so how is it gonna go? How is it gonna build it with 2? From 2 it can go only 0, 1, 0, 2, and from 1 it can go to 2, and from 2 it can go to 1, and of course C++ is always the longest motion. And from there basically it's an empty one. So it's an empty one, and from from there can go to 1 and can go to 2, and from 1 can go to 2, from 2 can go to 1. So basically for each number, if number is not in the current, here add it on the current, repeat the backtrack the current, and remove the current, because it's gonna to the empty one it's gonna push 1 2. So to the empty one it's gonna push 1 and call it on the array of 1. So first we call it on the first it gets called on the empty one and gets called on 1, and then 1 is inside and 2 is not, and then it's pushed, and then in the previous call we have 1 2, from where it will remove 2, and then we go to the previous one, and then it pushes 2, and it doesn't have 1, and I see. So for each number it's gonna go push each number inside. It's gonna push each number inside. Makes sense. It's gonna push each number inside. So for each, it will start from each number, but actually starting from here, and it's gonna start here, and then, and what if it doesn't remove it? So what if it doesn't remove it? Let's see what if it doesn't removing. Perms array. Sure, that's even shorter than the algorithm that I figured out. Christ. Okay. So what does it get? Numbers. Okay. Function backtrack. Sure. Okay. Crap. Where do they push that? Uns. Len nums uns append backtracker. Right. Uns. Yeah, they might have some kind of whatever. Push C. Return. Sure. So const number. So for each number, C push, C pop, and backtrack on C. Now I hope it's not infinite recursion. Of course it's infinite recursion. For number, if number is not in. How do you know? If is number not in array. Sure. So includes there. For const and if and backtrack current pend num. Yeah, it's not doing anything. Let me copy it. I need to figure that out. So let's see. Function btc as backtrack but there and there as push current there. Nums in array. Sure. If num not in current. So there and c pop n, but c should Christ. If it is not inside, let's just do this. Means it's not found, which means if it finds it, includes n. Maybe my naming is just off. Function backtrack permute nums backtrack cur if cur length nums length as push cur return there return ends track there. I mean, you can just do that. Permute backtrack. And you can say for const num of nums. I just made it, make sure it's right one. Sure. If not in cur includes num, if not in cur push num cur pop backtrack cur. That should give me the correct. Holy Christ! Right, I knew it was some JavaScripting or whatever immutability. Gotta make a copy. Jesus. Okay, and what I'm pretty sure here is that it's gonna be 1 and 2. One, two. I need the exact order. 1, 1, 2, 2, 1, 2. And what if you say 1? Okay, so first it's 1, and then it enters. Let me think. It's 1. I mean, I don't even know if this is gonna cut it because it never did before. So I must be doing something wrong. Number of, for each number of current, if number is not in the answer, then go back. And it's kind of obvious here that I have to go from here back, pushing on and going back, and I think this is wrong way to see it, wrong way to see it. I'm missing something. Maybe from here. Know that I'm doing a DFS traversal of an imaginary tree. Know that we are essentially implementing a DFS traversal of an imaginary tree. Now that's here, of an imaginary tree. The children of a node are all the numbers that haven't been used yet. Create a backtrack function that takes current as an argument. Create a backtrack function that takes current. Iterate for each number. If number is not in the current one, do the following: add number and then remove it. Okay, that's absolutely like my brain is like, it's just like, no, 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 I ain't gonna accept that. That makes no sense to me. I hate the feeling. When we return a function call to move, when we return, it's equivalent to moving back up the tree, exactly like in DFS. When we move from parent to child, we are adding an element. When we move from a child back to its parent, we need to remove the element. This is the backtrack step. So this is using reference. Because if I do slice here, it's not gonna work. It's gonna work. Huh. missing something. It just won't click. It just won't click. Won't click for me. Think of each call to the recursive being in the tree. In each call, let's see. It's 1, 0. Christ, find all permutations. Feels kind of painful, this process. Nope, nope. Well, okay. What do I get? That, let's say that I have element 1, 2, 3, 4, 5. Now I'm thinking 1, 2, 3, 4, 5. Take 1. If it is not currently added, then if it is not currently added, then call backtrack on it and just assume that it works and then go back. Which means basically if I'm saying here 1, it's gonna give me permutations of 1. If I say 2, it's gonna give me permutations of 2. 1, 2, 1, 3, 2, 1, 2, 3, 3, 1. Yeah. And why does it work? Because we are simply building up. We are building up. I have a number 1. So okay, let's do this. So we have this. For each number, okay, so the statement is for each number in numbers, if it is not currently in array, add it, repeat the same process for others, because we already added it. Remove the currently added. I don't get the remove step, maybe because it's solid. So in the end, you pay. I guess I pay in spending the time to understand their solution, or I spend the time rubbing my brain trying to figure out my solution. I will pay in the end. So what does it matter? Doesn't. And now if imagine that. So for each number, so I add 1. If it's not, then repeat the same process and then I remove 1. And now I have 1, 2. Remove currently added. And then I'm gonna be at 1. And when I return here, then I'm gonna be at 2. And it's gonna say repeat the same process for others. And remove the current one. Oh! Now I get it. Now I get it. Gotta remove it because gotta remove it. So to start, because if I don't remove it, so it's like we start with an empty one for each number. If number is not currently added, repeat for others, remove it. Because so you have this, so you start with 1, we're gonna start with 2, then we start with 3. So for example, if we have array these elements, we have an empty one, we start with 1, we start with 2, we start with 1, then remove it, then with 2, then remove it, then with 3, then remove it, then with 4, then remove it, then with 5, then remove it. And for this one, repeat the same process for the others. And if we use inductive step through the recursion and say that length is 1, so here length is 0, and since length is 1, that's it. But if we say repeat it for the others, now we have a starting array of 1, and we have 2, 3, 4, 5, because they are not inside. So it's gonna make 1, 2, repeat for others, remove 2. Right, I get it. It's shaky, but I get it. It's shaky, but I get it. So here, my cat. For each number, add it, repeat for others, and in order to continue, remove it. Because here, if I don't remove it, it won't work. Get it! Yippee yay! Now I gotta write it in C++. Now I need a backtrack, which I cannot define there. And I can do something like what? Return answer vector int answer. Whoop. There. Void backtrack vector of int current. Let's see, what do I need from variables inside? Vector int answer in initialize the len, I guess. No. Vector int nums. If current size is nums size, answer push back current there, and here out number of nums. Yeah, I don't know in C++ how do you write C++ number, not in vector. I guess there is some STL function count key for begin. If std count, okay. If count begin and n, answer begin, answer end, what does it std count, what does it even return? Count if, return value. Count if std int to count elements. If it's 0, I guess. Don't know what does it return. Count, answer begin, answer end, n. Sure. If it's not inside, current push back n, current pop back, and backtrack current. Sure. Answer nums. Backtrack. An empty one. Answer. It won't work because here it's reference and here I'm giving it all value. Backtrack. An empty one. Answer and nums. It won't work. It won't even compile. Well, here and current, I guess. I mean, I guess it can take a copy. Don't know if it's gonna work though. Answer. What does it say? Count. function requested here? Okay. No idea. Let's see. Find answer and okay. Still doesn't work. Instantiation of function template. Specialization. What's wrong? What's wrong with you? Tell me. Yeah, I don't care. I don't care. That the message is a note or additional. Yeah, the begin, the end, not the end. Answer begin, answer end. Find predicate. Compare, binary search. I mean, invalid operands to binary expression. Find the begin, the end, the key. Whew. No idea what it means. Let's try. I don't know. Find a begin, a end, 3. Okay, let's see what does it do now. Okay, can it work now? Answer begin, answer end, and current. Current, and current. Backtrack here. I mean, I can just say answer and nums. default value, if that's how it works. I don't know the syntax. There. Thank God that if you answer nums. Yeah, and I guess that's gonna cut it. Size, pop back. Great. Let's see if it's gonna work. 1, 2, 1, 4, 1, 2, 3, 4, 2, 3, 4, 5, 6. It should work. Great. Great, great, great. Faster than, less than. I mean, I guess it's not even the best one, right? Who cares? Anyway, gonna add it to my repo. Get add it. Oopsie. New. Permutations backtracking CPP. Did it create it? Pro. There is not even that much code. It formatted it. Alright. Int main vector num solution s permute for const auto answer cout and line. I mean, sure. And I can just do using namespace std include bits there. And here in terminal I just need to copy path, sub cd. Copy path, and I can just say cp permutations backtracking bats. Cool. I can at least say private. Okay. Push origin feed algorithms. There we go. It's formatted. I'm gonna that as well. There we go. Add comments of my third process. Push origin feed origins. Okay, let's cut it there. Till next time.